Hey guys, welcome to this video, and in this video we will understand how do you choose a right machine learning model. So there are many number of model out there. Of course, data science has no fixed syllabus, so each day, each period, each after quarter, after an academic study, there are machine learning model that are published. So because there's a maths behind it, people know how to create a machine learning model from scratch. And there are many, the community is that big that each day you see new machine learning models coming up. So how would you, as a beginner or as someone who is building a machine learning project, you're working in your company, how would you choose a machine learning model? Because this is a model that I should deploy or they should implement. Now one obvious answer that comes to mind, okay, the model which performs well, I'll choose that model, right? So whatever we have evaluation metrics, right, we have evaluation metrics such as recall, precision, accuracy, F1 score. So whichever model gives me a right best accuracy or best precision, recall, whatever my use case is, I'll choose that model. So is that the correct thing? Absolutely not. Why? Because yeah, obviously that sounds correct and it's a straightforward thing, but what will happen in that case is that you will end up trying a bunch of models, right? So the video is targeted towards how do you choose a model rather than how do you select a model. So choose a model basically has a pattern of thing. Okay, I'll try this model, then I'll try that model. So what is the ideology behind trying different models? And selecting it is different thing, right? That okay, the model whichever gives the best result is the best model, right? Now coming to our aim is that we'll take a simple use case. Okay, you've got the data. Let's say you are working in an industry and your manager gives you a particular data set which by your luck is clean. It's a clean tabular data set, okay, and it has one feature that has 0 or 1 label, and all of them are your dependent variable, so independent variables. So you have your bunch of independent variable and then you have your dependent variable. Okay, so if you guys have a bit idea of machine learning, this is a machine binary classification model, right? So this is a binary classification problem where you have to build a model that takes up a new data, which new data will have these number of features, and the data will have these number of features, and on the basis of that feature it will put that particular data either in 0 category or in 1 category. This is a problem statement that you have in your hand. So the idea behind choosing a machine learning model is coming from a different approach. We are not talking about like your rule based approach, which is something like this is a classification model, obviously, right? This is a classification model. There is no point of using linear regression or random forest regression or decision tree regression here. This is a classification problem. So obviously our category of choosing the model is now totally focused on the classification model, right? So we reject all the regression model. That is an obvious fact, right? We don't need to go into a depth of it. Bunch of model got cancelled just because of your problem statement. Now when it comes to classification of model, there is no we can make a particular pattern. Okay, I'll choose this model. If this does not work, I'll choose this model. If this does not work, I'll choose this model. But here we basically want to talk about your pattern of models, right? So what I'll do, the first thing that I'll select is basically your thought of what basically motivates you to move from one model to another model, right? So let's say I am starting out with like this is a classification problem, right? Let's say this is a health industry problem. So in that particular case I will be talking about recall. Now why in health industry we are talking about recall, that is completely a different topic of how do you choose a precision, how do you choose evaluation metrics, which we will discuss later. But today we'll talk about just about choosing a model. So let's say the metric that I have chosen is recall. So now what I want to do in this case is, recall is something that I can judge on all the classification model. So the idea comes from the trade-off between your complexity, right, and how complex your model becomes, and what is the variance that you're getting in your model, or you can say that is a bias and variance trade-off as well, but the idea is same, right? So, and in easy terms, let's say one more example, right? In easy terms, I would say that if I can get a result on a model that is your simple logistic regression model. Let's say I have a simple logistic regression model and I'm getting around 91% recall here. Okay, and let's say in other case on the same data set, when I'm applying a neural network, I'm able to get 93% recall. Right, now if you'll see simple analogy, if you just see this one simple idea is that you're having a 2% of increase in your recall, which is your target evaluation metric, and what results that you're getting, what is the what did it cost you? It cost you from moving to logistic network to a neural network. Basically you are increasing your complexity of model as high as it can be increased, right? And what this increase in complexity of model will cost us? This increase in complexity of model will cost us high money, of course, right? It will cost you high training time if your system is slow, and obviously it's cost you more resources. In general, we can say more resources in terms of, obviously you have to know someone who knows neural network. If you are doing it yourself, you need to have understanding of neural network, so obviously it costs you more resources, both in terms of money, knowledge, and in terms of your time. Same thing could have been done by logistic regression, and there was just 2% increase your recall. Now just assume this example in case of large method, not in your personal project. Just because, see, if I'm using it in my simple Jupyter notebook, these costs or these factors that I have discussed, okay, this will be the cost, this will be the factors that would be influenced if you're moving from that less complex model to that more complex model. So if I'm just doing it in my Jupyter notebook, that is all fine, right? Because this is not that viable cost. I won't even realize that what, of course, first of all, the model's usage is free, and then you don't need to have that much of a computation as well, right? If your project is small, everything is fine. Imagine this in the case of quite a big company. Let's say a company is making a application, it's a worldwide application, and that takes the image data, and on that image data we are doing this binary classification. So if you know image data, you know that binary classification what we are doing. In that case, this complexity would be huge. Obviously there would be a little hard to do logistic regression on image data, but just try to understand, okay, when it comes to a big complex problem, or let's say I'm talking about a banking application, I have like around 3 or 5 or 10 million of customers, right? And they 10 million of customers, obviously imagine how much data I have of those customers, and on that I'm performing this binary classification. So now this becomes a really huge problem, right? Because that complexity factor of 2% that we are having, right, the 2% increase in your 2% increase in your evaluation metric, that now becomes a little bit insignificant, because you're moving from 91% to 93%, and that is costing you this much amount of money, which the factors that we discussed, right? Money, this is be huge, right? Now you will be thinking just why this will be why these are factors, in fact, right? So money, basically, see, when you're doing it in Jupyter notebook, that is all fine, but when you're actually making an application that takes use of servers that that are not yours, or that you are using high computing servers, let's say my algorithm, or let's say my whole application is taking use of D2C clusters, or Kubernetes clusters, or any clusters or servers that I have taken on rent on cloud, right? So just imagine how much time it will take me to run these application on a less heavy cloud. You can say less cloud, for example, simple your CPUs. I'm not if I'm not opting for GPUs. If I opt for GPUs, my app performance would be higher, my customer feedback would be good. So ideally, as a business, I should go for higher GPU server so that my app will run properly, and these algorithm, the neural network algorithm on this 10 million of data, it will run properly. Okay, but what is this, what are we achieving after this? We are just achieving this 2% increase from 91% to 93%. Now this is the sole idea of how do you choose your algorithm. The basic idea that you should go with, and that I have always implemented while approaching a machine learning problem, is that you look for a smaller model, right? If like there's a, for example, this classification problem, so I'll start with logistic regression, simple logistic regression. I'll see my model, what results I'm getting. even if I know properly कि, okay, this will not give me good results, I'll try this because this is not got cost me that much. It's a simple model. It just it will not give me good results, I know this, right? But I'll try this and I'll see what results I'm getting. Next thing would be to increase the complexity of model a bit by bit. Remember guys, a bit by bit. What I have seen people doing, if okay, let's focus first. So I'll try with a logistic model. If I won't get good results on logistic model, I'll move to a decision tree classifier. Decision tree, okay, logistic regression, then decision tree classifier. Now you can use any other simpler model as well in case of decision tree classifier. I'm just using it because it's in the top of my mind and it's a bit complex than logistic regression and not that complex. Now if I'll see the results on my decision tree classifier, if the results are not that good, I'll move to random forest. Okay, I am moving to random forest. Now random forest is an ensemble model, right? And it's a little more complex than decision tree, but what it also does, it reduces your overfitting, it reduces noise because it's an ensemble model. Now this is a general approach guys. I am increasing complexity, random forest, then maybe I'll move to XGBoost and maybe I'll move to cat boost, you know, and I'll see whatever I'm getting good results for. The other idea is this, that I also monitor my results here, that what is happening here. Let's say in logistic regression, we got an accuracy, or sorry, the recall score that we're discussing. In logistic regression, forget the banking application. This is like, now comes the example of health application because I'm using recall. I don't want you to get confused that okay, why you're using recall in a banking application. Although in case of loan and all that thing, you would use recall. But let's say it's a health application or health machine learning model that detects some disease. So what I have here is I have a logistic regression. In this, let's say my recall was 62%, okay, or 0.62. Let's say my recall was 62%. When I move to decision tree, which is basically not that much of a use, but when I move to decision tree, my recall became let's say 84%, okay, and when I move to random forest, my recall became 85%. Now what does this gives you, right? So when I move to decision tree to random forest, my recall increased by 1%, right? But what other things would have changed while moving from decision tree to random forest is that I have increased the complexity of model, because random forest is basically a combination of decision trees. So instead of using one tree, now I'm using n number of trees, which can be anything, and that is giving me just 1% increase here, right? Basically that gives me an idea ki, hey, in your decision tree, overfitting was not that big an issue, right? There was other issue that you should fix. Overfitting was not that big an issue. It might be that I would have has a bias issue in my decision tree, right? Because overfitting was certainly not an issue. If overfitting would have been an issue, when I moved to decision tree random forest, the results would have been even more better than this 1% increase, right? So you have to use logics like these while selecting your models, right? Not just follow one trail. Okay, I'll just increase the complexity. That is not also correct, and that is not also correct. We are just choosing model at random, or just choose the best model that you know. Okay, let's just deploy a neural network and get the answer and just leave it. No, that is not an ideal solution. You might be able to do your personal projects nicely with them, but when you'll go into interviews, you will be asked question, why do you choose neural network? What will you answer? Okay, that was the best model that I knew, right? That is not the correct answer. There should be a logic behind it. Okay, why did you choose this particular machine learning model? Specifically when you're moving from your personal projects into industrial world, and your personal project is something that you're backing on, that is your main question that whenever I interview a person, I always ask, okay, why did you choose this model, right? And if I get this good answer, okay, there's a proper logic behind choosing that model, I'm quite impressed by that particular person. So that is the idea, guys. This is just one example. There are many use cases could be possible, right? There are many different scenarios that we could make based on different your evaluation metrics, different kind of models, right? Because you're moving from, in this example, you're moving from a decision tree model to an ensemble models. We know that ensemble models are based on the idea of majority, or they thought is that you use an ensemble model to reduce noise, to reduce overfitting, right? And if moving to a random forest model is not reducing your overfitting, that gives you idea that hey, overfitting was not a problem in your initial best model that you have got till now, which in our case was decision tree. Now what you could do here, what you could do in this particular case is that you can increase complexity in your decision tree only, right? You can increase complexity in your decision tree only and see the results. For example, decision tree has a parameter of depth. Okay, what depth you are going under your decision tree, you can increase that parameter and see the results, and it might be good. Let's say those results are good. Let's say what you do in this case is you increase the complexity of decision tree only instead of moving to ensemble model, and you see a decline in results. What that gives you an idea. If you see an increase in result, that's the idea that okay, your model need more complexity, so you move towards either a more complex model like boosting models or neural networks, but or SVM, right? But if your model is not giving you good results on increase in complexity of decision tree, in that case it's an indication that your model basically has like does not your data does not give you that much of a result, right? So you have to backtrack to your data, create some new features, create some new maybe increase your training data, and in that particular case, because you're not your data is not enough to have good result, that is the indication, right? In that case, what we do, we circle back to our data, either we create new features or we get new data, get more data, right? Or we do oversampling, right? So in this particular cases your machine learning knowledge is being quite thoroughly tested, and that is the beauty of machine learning. There's so many variables out there that you have to collect them, you have to keep a note of things, and as you move towards practice, as you move towards more simpler machine learning models and the fundamentals of it, you see the idea, okay, what things are changing, what I have to do, right? And that is why what I believe is, sometimes student lacks, because they learn one machine learning model, okay, what is linear regression, how do you train linear regression, that's fine, next move to next. You don't connect those models, right? You don't connect your previous learning to a new learning, and that becomes a problem, because in the end you feel lost. You don't feel what subject you have learned, you just remember individual topics. So that is the idea behind choosing your model, guys. This is just a basic understanding of how do you choose your model. My aim was to just influence your thought process of choosing model, not give you something like a cheat sheet or something like a rule book. Okay, choose one, choose this, do this. It's never like that in data science, and that is the beauty of it. So yep, and that was it for this video, and we'll see many more small topics about data science in this small series that I'm making about fundamental topics of data science. You can say I'm not named a playlist yet, but yeah. So you can connect with me on LinkedIn, you can connect with me on Instagram. I'll post both the links in the description of this video. And happy learning, keep learning data science. It's an evolving field. It's changing the course of industry, and it will keep changing the course of industry. So yeah, I'll see you at at some position which I'll be proud to stick, okay, the guy has seen the video. So yeah, thank you and happy learning.